Hello everyone. In today's class, we are going to continue with conic sections. In the last class, we had studied about circle and parabola. Today, we are going to study about ellipse. Ellipse is a set of all the points in a plane whose sum of distances between two fixed point in a plane is a constant. This is going to be the definition of ellipse. The two fixed point are called foci, which is the plural for focus of the ellipse. The two fixed point are called foci, right? The same thing has been given over here. So again, you need I had given this two times, so you need not take this two times. The only thing, the definition you have to know is ellipse is set of all the points in a plane such that the sum of distances from a fixed point is a constant. Those two fixed point are called focus, f1 and f2. So I can tell P1 F1, the distance P1 F1 plus P1 F2. P1 F1 plus P1 F2 should be equal to P2 F1 and P2 F2. Similarly, that also should be equal to P3 F1 and P3 F2. Basically, if you take any point, the distance between this point and the two focus, the sum of the two distances should always be a constant. Then I can tell these all the set of points will constitute an ellipse. Next, we have major axis and minor axis, right? Similar to the center of the circle, the midpoint of the line segment joining the two foci, the midpoint of the line segment which is joining the two foci is called the center of the ellipse. The line segment which passes through the foci and the ellipse and which touches the ellipse and also passes through the foci, that is called major axis. And the line segment through which the line segment which passes through the center and it is perpendicular to the major axis is called the minor axis. So this is going to be the minor axis, this is going to be the major axis of ellipse. The endpoint of the major axis are called vertices of the ellipse. So these are going to be the vertices of the ellipse, right? The endpoints of major axis is called the vertices of the ellipse. Next, we donate or we do, denote the length of major axis. The length of major axis from here to here. This one, the red one, we denote it by 2a. The distance from the center to this point is going to be a. Again, from this point to this point is also a. The total major axis, the length of major axis is taken as 2a. Similarly, the length of minor axis, this one is going to be the minor axis. This one is taken as 2b because the distance from this point to this particular point, this is taken as b, and from this point to this point, even this is b. You add these two, b plus b, you will be getting here 2b. And the distance between the foci from here to here, from this point to this point, this is going to be c. From this point to this point, this is also going to be c. So the distances between the two foci is going to be 2c. From here to here, it is going to be 2c. Next, the length of semi-major axis. The length of semi-major axis is denoted by a, and the length of semi-minor axis is denoted by b. So the distance from this point to this point, this is going to be a. The distance from this point to this point, it is going to be b. The distance from the center to the foci, it is going to be c. Right? I think somebody has joined. Let me just quickly let them in. Sorry, this is the other chat. Yes. Next, the relation between semi-major axis, semi-minor axis, and the distance of the foci, focus from the center of the ellipse. Now, if you know Pythagoras theorem, understanding the relation between semi-major axis, semi-minor axis, and the distance of the focus is going to be very, very easy. Now, consider this triangle QOF2. This triangle, since the angle F2OQ is 90 degree, I can tell that this forms a right angle triangle. In a right angle triangle, Pythagoras theorem holds good. So if the distance QO is going to be B, OF2 is going to be C, and QF2, this is taken as A, right? If this is taken as a, then sorry, the distance from this point to this point, if this is taken as a, I can write a relationship between a, b and c, which is going to be equal to a, which is given by, or a square is given by b square plus c square. This is going to be the relationship between semi-major axis, semi-minor axis, and the distance from the center to the foci, right? So this is going to be the relationship. A square is going to be b square plus c square. Next, we have standard equation of ellipse. There are two possible orientation for ellipse. One which is elongated along the x-axis, another one which is elongated along the y-axis. The equation for the ellipse which is elongated along the x-axis is given by x square divided by a square plus y square divided by b square is equal to 1. The one which is elongated about the y-axis, it is given by x square divided by b square plus y square divided by a square is equal to 1. The only difference is we have to shift a square and b square. That is the only difference, where a and b are going to be the constant, right? A is going to be the length of major axis, b is going to be the length of minor axis. Next, for the two possible orientation, I have written down 6 points which are going to be necessary to solve any problem. Okay, for the two orientation, the first one is going to be an ellipse which is elongated along the y-axis. Okay, if any ellipse is elongated along the y-axis, the equation is given by x square divided by a square plus y square divided by b square is equal to 1. And in this case, a is going to be larger than a is going to be larger than b. Now, for this type of ellipse, the coordinate of focus is given by c comma 0 and minus c comma 0. C comma 0 minus c comma 0. The vertices, coordinate of the vertices is given as a comma 0 and minus a comma 0. This are going to be the vertices. I'll be writing v over here. I'll be writing v over here also. These a and b are the vertices. The length of the major axis is given by 2a. The length of the minor axis is given by 2b. Eccentricity is a ratio between c and a. The ratio of c and a is called eccentricity. The length of the lattice rectum is given by 2b square divided by a. The length of the lattice rectum is nothing but it is a perpendicular line segment which is passing through the focus and perpendicular to the major axis. This is going to be the lattice rectum. The length of the lattice rectum is given by 2b square divided by a. So this is going to be the orientation, one of the orientation where it is elongated along x-axis. Similarly, if we have an ellipse elongated along y-axis, for this type of ellipse, the equation is going to be x square divided by b square plus y square divided by a square is equal to a is equal to 1. I'm sorry. Here in this case, b is going to be greater than a. So I will go back to the previous slide. When an ellipse is elongated along x-axis, A is greater than B. When an ellipse is elongated along y-axis, B is greater than A. Now, the coordinate of focus for this type of ellipse is going to be 0, C and 0, minus C. The coordinate of the vertices is given by 0, A and 0, minus A. Length of major axis, minor axis, eccentricity and lattice rectum. All these four will remain the same for both orientation. All these four are the same for both orientation. However, the coordinate of focus and the coordinate of vertices will differ for the orientation. One which is along the x-axis, another which is along the y-axis. For the x-axis one, the coordinate of focus is c comma 0 and minus c comma 0. Coordinate of vertices is a comma 0 and minus a comma 0. For the one which is elongated about the y-axis, the coordinate of focus is 0, c and 0, minus c. Coordinate of the vertices is 0, a and 0, minus a. So only these two are going to be different. All the other four will remain the same. Now I am going to take up similar problems from 11.3. In each exercise 1 to 9, find the coordinate of foci, the vertices, the length of the major axis, the minor axis, the eccentricity, and length of the lattice rectum of the ellipse. First question, x square divided by 36 plus y square divided by 16 is equal to 1. The first step that I am going to take is to determine which of the denominator is greater. I observe that on comparing 36 and 16, 36 is greater. 36 is greater than 16. I can tell that the denominator of x square is going to be greater than the denominator of y square. The major axis will lie now on the x-axis and minor axis will lie on the y-axis. Whenever major axis is lying on x-axis and minor axis is on y-axis, the equation of the ellipse is given by x square divided by a square plus y square divided by b square is equal to 1. Now let me make a note of the question given to me. X square divided by 36. 36 can be written as 6 square. Similarly, 16 can be written as 4 square is equal to 1. Now I will be comparing the given equation with the standard equation, comparing both equations. I will be getting the value of A as 6. I will be getting the value of B as 4. So I have got the value of A, I have got the value of B. Next, I need to find the value of C. I know the relation between A, B and C. I know that A square is given by B square divided by C square. I know what is A, I know what is B. I need to find out what is C. C can be written as root of A square minus B square. C is going to be A square. A square is going to be 36 minus B square is going to be 16. C can be written as root of 20. Root 20 further can be written as 2 root 5. Right? I have found the value of A, B and C. The same thing I'll be making a note over here. It is going to be 6 and B is 4. This is 2 root 5. Now, coordinate of the focus. I have to find the coordinate of the focus. Coordinate of the focus is given by c comma 0 and minus c comma 0 for the ellipse which is elongated about the x-axis, which is given by x square divided by a square plus y square divided by b square is equal to 1. So c comma 0, I can write over here 2 root 5 comma 0 and minus 2 root 5 comma 0. These are going to be the coordinates of focus. Coming to the coordinates of vertices, a comma 0 and minus a comma 0, 6 comma 0 and minus 6 comma 0. Length of major axis is 2a. 2 multiplied by 6, it is going to be 12 units. Next, the length of minor axis is 2b. 2 multiplied by 4 is going to be 8 units. Eccentricity is given by c by a. C can be taken as 2 root 5 divided by a which is 6. I can cancel out 2 and 6 and I can write 5 divided by root 3. This is going to be the eccentricity. Length of the lattice rectum is given by 2b square divided by a. 2 multiplied by b square. B square is going to be 4 square divided by a, which is going to be 6. I can cancel this out 3 and this is going to be 1. The length of the lattice rectum I will be getting as 16 divided by 3. I have got the coordinate of focus. I have got the vertices. I have got the major axis also. I have got the minor axis also. I have got the eccentricity and the lattice rectum. Let us move on to the next question. Fourth question, x square divided by 25 plus y square divided by 100 is equal to 1. The first step is going to remain the same as we have taken for the first question, but the only difference is we have to first see or observe the denominator, which is going to be greater and which is going to be smaller. Now, in the question, I can observe that denominator of y square is greater than that of denominator of x. Right now the major axis will lie on the x-axis and the minor axis will lie on the x-axis. Sorry, the major axis will lie on x-axis and the minor axis will lie on the uh, x-axis. So your equation is going to be x square divided by b square plus y square divided by a square is equal to 1. Now we are talking about an ellipse which looks like this. which looks like an egg, which is elongated about the y-axis. Previous question, the first question, we had taken an ellipse which is elongated about the x-axis. This is the only difference. When it is about the x-axis, the equation is x square divided by a square plus y square divided by b square is equal to 1. When it is elongated about the y-axis, or when the denominator of y is greater than x, the equation is going to be x square divided by b square plus y square divided by a square is equal to 1. Let me take the equation which is given to me. It is x square divided by 25, which can be written as 5 square, plus y square divided by 100 can be written as 10 square is equal to 1. On comparing both of the equation, I will be getting the value of a and b. I will be getting the value of a as 10 now, and the value of b is going to be 5. I've got the value of a, I have got the value of b. I can easily find out the value of c. C is given by root of, it is going to be a square minus b square. A square minus b square. C is going to be 100 minus 25, which is root of 75. Further simplifying, I can write 75 as 5 root 3. I've got the value of A, B. A is going to be 10, B is going to be 5, and C is going to be 5 root 3. I can find out the coordinate of the focus. Now, the coordinate of the focus for the equation x square divided by b square plus y square divided by a square is equal to 1. For this, it is given by 0, comma c and 0, comma minus c. My answer is going to be 0, comma 5 root 3 and 0 comma minus 5 root 3. Coming to the coordinates of the vertices, it is going to be 0 comma a and 0 comma minus a. I can write 0 comma 10 and 0 comma minus 10. Length of the major axis is 2a. 2 multiplied by 10, it is going to be 20 units. Length of minor axis is 2b. 2 multiplied by 5 is going to be 10 units. Eccentricity is c divided by a. C is 5 root 3 divided by a, which is going to be 10. I can write this as root 3 divided by 2. The length of the lattice rectum is given by 2b square divided by a. 2 multiplied by b square, which is going to be 25, divided by a, which is going to be 10. This is 1 time, this is 5 times. I can cancel this out and I will be getting the value as 5. I have found out the coordinates of the focus, vertices, length of major axis and minor axis, eccentricity, and also the lattice rectum. We will move on to the next question. X square divided by 49 plus y square divided by 36 is equal to 1. First step is going to be to observe which denominator is greater. I can observe that the denominator of x square is greater than that of y square. So the major axis will lie on the x-axis and minor axis will lie on the y-axis. For this orientation, the equation is given by x square divided by a square plus y square divided by b square is equal to 1. I can compare the given equation. Given equation is x square divided by 49. 49 can be written as 7 square plus y square divided by 36. 36 can be written as 6 square is equal to 1. On comparing both, comparing the equations, I will be getting the value of A as 7. I'll be getting the value of B as 6. Once I have got the value of A and B, I can easily find out the value of C. The value of C is given by A square minus B square under the square root. C is going to be under the square root of 49 minus 36. 49 minus 36 is going to be 13, right? C is taken as root of 13. I've got the value of A, B, and C. Let me make a note of that. It is going to be 7, 6, and root 13. Coordinate of the focus is given by C, 0 and minus C, 0. It is root 13, 0 and minus root 13, 0. Coordinate of the focus is a, 0 and minus a, 0, 7, 0 and minus 7, 0. Length of the major axis is 2a. 2 multiplied by 7, it is going to be 14 units. Length of minor axis is 2 into b. 2 into 6, it is going to be 12 units. Eccentricity is given by c divided by a. C is root 13 divided by a is going to be 7. The answer is root 13 by 7. Length of the lattice rectum is 2b square divided by a. 2 multiplied by b square. B square is 36 divided by a. A is going to be 7. So you anything you can cancel? No, nothing you can cancel. You can write this as 72 divided by 7. This is going to be the answer for the lattice rectum. We have found out the coordinate of the focus, vertices, major axis, minor axis, eccentricity, and also the lattice rectum. Let me take one more problem. The sixth question: x square divided by 100 plus y square divided by 400 is equal to 1. Step 1 remains the same. Observe which of the denominator is greater. I observe in this question that the denominator of y is greater. When the denominator of y is greater, the major axis will lie on the y axis and the minor axis will lie on the x axis. For this type of orientation, the equation is given by x square divided by b square plus y square divided by a square is equal to 1. I can make note of the given question. X square divided by 100 can be written as x square divided by 10 square plus y square divided by 400 can be written as 20 square is equal to 1. On comparing the equations, I will be getting the value of a value is going to be 20, b value I will be getting as 10. Once I have got the value of a and b, I can easily find out the value of c. C is given by a square minus b square. A is going to be 200, c can be written as 400 minus 100. C is, or it can be written as root of 300. Now, once I have got the value of A, B, and C, I just need to substitute the same. Let me make a note of A, which is 10. B is going to be, A is going to be 20, B is going to be 10, and C is going to be root of 300, which can be written as 10 root 3. The coordinate of the focus is 0, comma C. 0, comma 10 root 3, and here it is going to be 0 comma minus 10 root 3. Coordinate of the vertices is given by 0 comma a and 0 comma minus a. It is 0 comma 20 and 0 comma minus 20. Length of major axis is 2 multiplied by a. 2 multiplied by 20 is going to be 40. Length of the minor axis is going to be 2 multiplied by b. 2 multiplied by 10 is going to be 20. Eccentricity is c divided by a. 10 root 3 divided by 20 can be written as root 3 divided by 2. Length of the lattice rectum is 2b square divided by a. 2 multiplied by b square is 100 divided by a is 20. 0 and 0 will be getting cancelled. 2 and 2 will be getting cancelled. You will be left with